In the previous lesson, we learned that the Pythagorean theorem can be used to solve for a missing side in any right triangle. There are two special right triangles that we can find missing sides given one side if they have specific angles. There's a special relationship between the sides of the triangles. So our first special right triangle is a 45, 45, 90 degree triangle. And what that means is it's a right triangle and both of the angles are 45 degrees. That means that it is isosceles, so both of the legs are congruent. So in this figure, those legs, we're just going to call them x and x. Now, if we use the Pythagorean theorem to find the hypotenuse, it would be x squared plus x squared equals, and I'm just going to call the hypotenuse c squared. X squared plus x squared is 2x squared equals c squared. And then if I take the square root of both sides, the square root of 2 is just the square root of 2. And the square root of x squared, they undo each other, so that's just x. So instead of having to use the Pythagorean theorem every time, you automatically know that the hypotenuse is the leg times the square root of 2. And for these special right triangles, we are going to leave them in simplest exact form, so we are not going to get the decimal value for these sides. So in a nutshell, if you know the 45, if you have the legs, those are across from the 45 degree angle, then to find the hypotenuse, you're going to multiply by the square root of 2. However, if you have the hypotenuse, which is across from the 90 degree angle, and you want to find the legs, you're going to divide by the square root of 2. So let's look at a few examples. So for number 1, we have that one of the legs is 8. So that means the other leg is 8. So x is 8. The hypotenuse, although we could do the Pythagorean theorem, the hypotenuse is going to be the leg times the square root of 2. So y would be 8 root 2. And again, we're going to leave these, that's simplest exact form. We are not going to turn them to decimals. So really, you don't even need a calculator for that particular problem. Some of them you might want to help you simplify depending on the values of the legs or the hypotenuse. But a lot of these can be done without a calculator. So on number 2, we have another leg, which is 25. So that means the other leg is 25. So y is 25. And then the hypotenuse, because it's a 45, 45, 90, will be the leg times the square root of 2. So 25 root 2 for x, or the hypotenuse. On number 3, again, it's a 45, 45, 90 triangle. You can see it's got the 90 degree angle and the 45 degree angle. That makes the other angle 45 degrees. But this time we have the hypotenuse. So to get to the legs, we need to divide by the square root of 2. If you have a calculator that simplifies square roots, you could definitely put that in there. That's the quickest way to do it, but I'll also show you how to do it by hand. So that would be 14 root 2, and that means both the legs are going to be 14 root 2. Now, if you don't have a calculator and you do this by hand, you have to do what's called rationalizing the denominator. You have to get rid of the square root in the denominator. So what you do is you multiply both numerator and denominator by root 2, because root 2 over root 2 is 1, and you can multiply anything by 1. And in the top, that gives you 28 root 2. But in the bottom, it gives you root 4, and root 4 is just 2. So essentially, they kind of cancel each other out, and 28 divided by 2 is 14. So that ends up being 14 root 2. Again, if you have a 36X Pro, no problem, put in 28 over root 2, and it'll simplify it automatically for you. Just make sure you're using the fraction button and not the division button, because if you use the division button, then it is going to give you the decimal value. Most likely. But if not, it's fine. You want to just make sure you have it in simplest exact form. On number 4, we also have the hypotenuse in the 45, 45, 90 degree triangle. So to find the legs, we are going to divide by root 2. If you have a calculator, type that in. We don't want to leave that root 2 in the denominator. If not, multiply by root 2 over root 2, which gives you 19 root 2 over 2. And this time, 2 doesn't go into 19, so we'll just leave it as 19 root 2 over 2. And that's going to be both x and y because the legs are the same since this is an isosceles triangle. So to recap, in a 45, 45, 90 degree triangle, if you have the legs are the same. And then to find the hypotenuse, you multiply by the square root of 2. If you have the hypotenuse, you will divide by the square root of 2 to find the legs. Our second special right triangle is a 30, 60, 90 triangle. And a 30, 60, 90 triangle comes from half of an equilateral triangle. So in an equilateral triangle, all of the sides are the same and all of the angles are the same. So they're all 60. But when you split that in half, that splits that top angle to 30. So this becomes 30, 60, 90. So if this was 2x, this was 2x, and then this third side was 2x, but it got split in half, so that's x and x. So we could use the Pythagorean theorem to find that missing side, that missing leg, but what you'll find out is that the relationship of that side that's across from the 60-degree angle, that's the longer leg, is going to be the shorter leg times the square root of 3. So the shorter leg is across from the 30-degree angle. We're going to call that x. The longer leg is across from the 60-degree angle. We're going to call that x root 3. And then the hypotenuse, which is across from the 90-degree angle, will be double the shorter leg. So this one's a little bit more complicated because you do have 3 separate sides, so you just need to make sure you know the rules for each side. So let's say that you're given the 30-degree angle. That's the easiest way. To find the hypotenuse, which is across from the 90-degree angle, you multiply by 2. To find the longer leg, which is across from the 60-degree angle, you multiply by the square root 3. Now, if you are given the hypotenuse, which is across from that 90-degree angle, to find the shorter leg, which is across from the 30-degree angle, you divide by root 2, and then once you have that, then you multiply by root 3 to find that longer leg. Finally, if I give you the 60-degree angle, you got to find that shorter leg first. So you're going to divide by root 3, and then once you divide by root 3, once you get that shorter side, to find the hypotenuse, you multiply by 2. So let's try some examples because that can be a little bit confusing. We've got a few more examples of these compared to the 45, 45, 90. All right, so in example 5, we have a 30, 60, 90 degree, a right triangle. So we've got the right angle marked, the 60 degree. That means the other angle is 30. So that means 5 is our short side. Okay, if you're given the short side, to find the hypotenuse, you double it. So 5 times 2 is 10. If you have the short side, to find the longer leg, you multiply by the square root of 3. So that would be 5 root 3. So just to kind of draw it out here. All right, x, hypotenuse is 2x, long leg is x root 3. This is the easiest case scenario if they give you the shorter leg. We have to work backwards if they give us the long leg or the hypotenuse. So let's see, x was 5 root 3. And y, our hypotenuse, is 10. All right, in number 6, they also gave us the short leg. We know that because it's across from that 30-degree angle. So to find the hypotenuse, we're going to double it. So that's 28. And then to find y, we're going to multiply by the square root of 3. Now, if you use the 14 and the 28 and you did the Pythagorean theorem, you would get 14 root 3 once you simplified everything. but that's kind of why we have these shortcuts, so that you don't have to do the Pythagorean theorem. So x was our hypotenuse this time, that was 28. Y was that longer leg, which is 14 root 3. All right, and number 7, again, 30, 60, 90 triangle. Our short side this time is x. Our long side is y, but they gave us the hypotenuse. So again, just going to kind of draw out your rules to the side. X is your short side, 2x is your hypotenuse, and then x root 3 is your long leg. So because they gave us the hypotenuse, we're going to use that to find x, that shorter leg. So if the hypotenuse is 2x, then to find the shorter leg, we would divide by 2. 32 divided by 2 is 16. And then once we have that shorter leg, to find the longer leg, we do x times the square root of 3. So it's going to be 16 root 3. So x is 16, y is 16 root 3. For number 8, again, they gave us the hypotenuse. So we're going to find the shorter leg. The shorter this leg this time is y. So we're going to divide by 2. 46 divided by 2 is 23. And then the longer leg, which is x, will be 23 root 3. All right. On 9 and 10, both of these, we have the longer leg, and we need to find the short leg and then the hypotenuse. So again, our short leg is x, our hypotenuse is double x, and then our longer leg is x root 3. So I'm actually going to do number 10 first, just because I think it's going to be a little bit easier than number 9. So since we have the longer leg, we want to find the short leg. So if the short leg, if you have the short leg, you multiply by the square root of 3 to get the longer leg. So if they give you the longer leg, you're going to divide by the square root of 3. And what's nice about this one is those root 3's cancel, and that just leaves you with 9 for x. And then to find the hypotenuse, you double that short leg, so y is 18. On number 9, our long leg is 20. So when we divide by root 3, this is not going to work out nice and pretty. So you either use your calculator or you rationalize the denominator by hand. So I'm going to do it by hand. I'm going to multiply both numerator and denominator by root 3. In the top, that gives us 20 root 3. In the bottom, it gives you root 9, but root 9 is just 3. So our short side is 20 root 3 over 3. That's kind of an ugly looking answer, and sometimes that's going to happen depending on the values that you're given for your sides. But don't freak out. And again, if you have a calculator, it makes it really easy. You can just type in 20 divided by root 3, and it will take you straight to 20 root 3 over 3. Sorry, I wrote 2. Let me fix that. Now to find the hypotenuse, we have to double that. When you double that, all you're doing is multiplying the numerator by 2, and you're just going to multiply the 20, the coefficient, by 2. So it becomes 40 root 3 over 3. You can't cancel out those 3's because one is in a radical and one is not. So uglier answer, but process is still the same. All right, now we're going to look at some join special right triangles where we're going to be finding multiple sides. So we, in 11, have a 30, 60, 90, and then we also have a 45, 45, 90. So the only side they give us is 17, and 17 is the shorter leg in that 30, 60, 90. So we're looking for x, which is the longer leg, so we are going to multiply by the square root of 3. So x is just 17 root 3. Now, it doesn't ask me to find the hypotenuse in that 30, 60, 90 triangle, but I need to find it because the hypotenuse of the 30, 60, 90 is a leg of the 45, 45, 90. So to find the hypotenuse, we're going to double that short leg, so that's going to put the hypotenuse at 34. But if that is 34, right, that's the leg in the 45, 45, 90, then Z will also be 34 because a 45, 45, 90 is an equilateral triangle. And then to find the hypotenuse, we multiply by the square root of 2. All right. Also a 30, 60, 90 and a 45, 45, 90. This time they gave us one of the legs in the 45, 45, 90. So because it's isosceles, then X will also be 14 root 2. We are not asked to find the hypotenuse of that 45, 45, 90, but we need to find it because it is also the hypotenuse in the 30, 60, 90. So to find the hypotenuse, we multiply the leg times root 2. And again, you can use your calculator or you can do this by hand. That would be 14 root 4, but root 4 is 2, so it just becomes 14 times 2, which is 28. So again, that's not a specific piece they asked us to find, but we need to find that because now we have the hypotenuse in the 30, 60, 90. So to find the short leg, which will be y, we're going to divide by 2, which is 14. And then to find the long leg, we are going to multiply by the square root of 3. So 14 root 3 for z. All right, this time we have the hypotenuse in the 45, 45, 90. So we need to first find the leg because that's what z is. If you have the hypotenuse in a 45, 45, 90, you divide by the square root of 2. Use your calculator or do it by hand. It's going to give you, you're going to multiply both numerator and denominator by root 2 over root 2 because that's the same thing as 1. You get 20 root 2 over root 4, but root 4 is 2, and then 20 divided by 2 is 10. So this becomes 10 root 2. So both of the legs in the 45, 45, 90 are 10 root 2. So we have z. Now, the top leg in that 45, 45, 90 is the long leg in the 30, 60, 90. So to find the short leg, we have to divide by the square root of 3. So this one kind of gets a little bit ugly. But again, if you have a calculator, it should not be a big deal. It will simplify everything for you. So let's do that. I'm gonna again do it by hand, just like I've done every time, so that you can see how it works. But we're gonna multiply. We want to get rid of the root 3 in the bottom, so we multiply by whatever that square root is in the bottom. In the top, that's going to give us 10 root 6. And then root 3 times root 3 is root 9, and root 9 is just 3. So that means our short leg is 10 root 6 over 3. Ugly looking, but that's exact form. And then to find x, we just need to double that. So we just multiply the numerator by 2. Only the coefficient gets multiplied. Make sure you don't multiply the radicand. So it's 20 root 6 over 3. All right, we've got one more problem. So we've got, again, a 30, 60, 90 and a 45, 45, 90. This time they gave us the long leg in that 30, 60, 90. So if we have the long leg, we divide by the square root of 3 to find the short leg. And luckily this one works out nice and easy. Those root 3s just equal 1, so it gives you just 6. To find the hypotenuse, even though I don't need to find the hypotenuse, even though it doesn't ask me to find the hypotenuse, I do need to find the hypotenuse. You double it. And the reason we need that is because that is the leg in the 45, 45, 90 triangle. So that means that y is the same thing because it's isosceles. So y is 12. And then to find the hypotenuse, we multiply by the square root of 2. And that is all for special right triangles. Just make sure you know your relationships between the sides and the hypotenuse in both a 45, 45, 90 and a 30, 60, 90. In the 45, 45, 90, it's isosceles, so the legs are x and x, and then the hypotenuse is x root 2. So if you have the legs, multiply by root 2. If you have the hypotenuse, divide by root 2. In your 30, 60, 90, x is the shortest side, which is across from the 30-degree angle. If you're looking for your long leg, you do x times root 3, shorter leg times root 3. If you're looking for your hypotenuse, you double the short leg. If I give you your hypotenuse, cut it in half to find the short leg, then multiply by root 3 to find the long leg. If you're given the long leg, divide by root 3 to find the short leg, then double to find the hypotenuse.